Hey guys, this is Mrs. Tran-Bloom recording section 1.5, square root operations. In your box, you have a couple blank lines there. This is the part where you want to fill in the blue highlights here, or not highlight, the blue words here. So when you're adding and subtracting radicals, you kind of do it in the same way as if you were doing adding and subtracting variables. First, you want to combine like terms. Then once you're done combining like terms, just like other adding and subtracting expressions, you want to simplify the radical. Now, to simplify the radical, we studied this already. Once the radical is in its simplest form, then you can add like radicals, okay? Now, like radicals meaning that the radicand, which is the number under the square root, it's the same, or under the cube root. Those number under the radical symbol is the same. And also like index. The index is the square root, cube root, fourth root, and so on and so on. Both, very important, both must be exactly the same for you to say those are like radicals, okay? Examples 1 to 3, add or subtract. Express each in the simplest radical form and as a decimal approximation rounded to the hundredths place. So when I'm doing adding radicals or adding any algebraic expression, I normally like to put whole numbers together and then in this case all the radicals next to each other. So 4 plus 9, that will give us 13. Now this is square root of 5 and square root of 5. Notice how both of them have 5 under the radical symbol. Now, notice I said square root, so that means the index is 2, which is identical. Once that's the same, then we know that 3 and 2 added together, you will get 5. You do not add the numbers under the radical symbol. So that's done. We box it up. Now, the instruction said that we need to use your calculator and give us a decimal approximation. Some calculators are different. So we know that we want to find the approximation for square root of 5 here. We know 4, 5, 6, 7, 8, and 9. Out of all these numbers, only 4 and 9 are perfect square numbers. While square root of 4 is 2, square root of 9 is 3. So we know 5, 6, 7, 8, those have to be, square root of those have to be in between 2 and 3. This is how you test how to use your calculator. So you want to turn on your calculator, and in my case I have this, not very fancy, but it works. I want to test out, hey, do I enter in the square root symbol, okay, first? So for example, my square root is, I have to hit the second button, square root 5, and then see, it doesn't do anything. It gives me the answer 5 still. So obviously that is incorrect. Now I'm going to clear that out. What if I put 5 and then I go and enter in square root? Okay, now I know that works. So my calculator, to use the square root button, I have to enter in the number and then the square root function. So now I can enter in 13 plus, so 13 plus. Now because I want to do 5 times square root of 5, I want to do parentheses 5 times. Remember, my calculator wants me to enter 5 first, then the square root, and then close up that. Now again, your calculator may be a little more advanced and you can enter in things differently, but make sure we know how to use our own calculator. So the right answer is 24.18. I'm going to go back, enter that in, and box it up. Let's move on to example 2. 4 square root of 27 plus 3 square root of 3, take away square root of 48. Now the first thing we want to do is simplify the radical. Well, I know 27 is going to be 9 times 3. 3 on the outside, square root of 3, that's already a prime number. Square root of 48, if you don't know the biggest square number, we can always start with number 2 or number 4, and then we can break those down. I'm going to start with number 4, because 48 divided by 4, I'm going to get 20. Sorry, not 20. I meant 12. Okay. So 12. There you go. So from here, we can simplify a little bit further. So 4 times square root of 9 is going to be 3. I'm left with a 3 under the radical still. 3 times square root of 3 is the simplest that you can have. I know square root of 4 is going to be 2. Well, 12, I can break that down to 4 times 3. So 4 times 3 over here is 12. 12 rad 3 plus 3 rad 3 minus 2. Again, square root of 4 is going to be 2. And then rad 3 is under. 12 rad 3 plus 3 rad 3, that's going to be 15 radical 3. Take away 4 radical 3, that will give me 11 rad 3. That's the simplest radical form that we can have. Now it's our job to go and try to find the calculator and enter that in. Why don't you practice, enter that in, and then see if you can match my answer. So I have an answer of 19.05. I'm going to go back, enter that in. Okay, so let's move on. So example 3 says radical 32 plus 5 radical 18. 32, we can simplify that down to 16 times 2. Then 5 square root 18. 18 is 9 times 2. Square root 16 will give me a 4. So 4 square root of 2 plus 5 times square root of 9 is really 3. So 3 square root of 2. So 4 square root of 2 plus 15 square root of 2. As you can see, you have the same index, which is square root of 2. And I'm sorry, which is a square root, and then 2 is the radicand. So these are like radicals. We can combine them. This will allow us to write 19 square root of 2. Box that up. Now your job is to go and use your calculator to give me the decimal approximation. And if you need to, again, hit pause until you're done. Now we are moving on to simple multiplication. Again, in multiplying, you will multiply the radicand. You will multiply the coefficients, and then once you're done, simplify. Similar directions to earlier, you're going to multiply, express your answer in the simplest radical form as well as decimal approximation to the hundredths place. In this case, we do have coefficients. They just happen to be 1. So 1 times 1 is 1, which normally it's a common number, so we don't really write it, okay? What we do have are the radicand 6 and 15. We're going to multiply those. You can sit here and multiply 6 times 15. I normally don't do that because we would have to simplify during the last step anyway. So I normally, honestly, break these down into prime numbers or perfect square numbers because it's easier for me to simplify as I go along. A square root of a pair, you will be able to take that out. You have a 2 times 5, that's going to give me 10. So under the radical, we will have 10. This final answer is 3 square root of 10. You will need a calculator to give the decimal approximation. Now this one, we have coefficients that are not 1, so I normally like to write them in the front, multiply those together. Then the radicals, I normally multiply them under the radical. So this is 12 times, just like earlier, I don't really multiply them. I like to break them down into prime numbers or square numbers. So square root of a pair of 2's, that will allow me to simplify that, simplify that out. So 12 times 2 times square root of 5, this will give me 24 square root of 5. Box that up, and again you will need to use a calculator to give me the decimal approximation. Next would be -2 times square root of 20 times 5 rad 12. Again, the coefficients, we will put them in the front. All of the radicands, we will write them inside. This will give us -10 in the front. 20 is going to give me a nice square number of 4 times 5. 12 also gives a nice square number of 4 and a 3. We have a pair of 4s here. We can definitely simplify that out of the radical. Inside we have 5 times 3, that will give us 15. So final answer is negative 40 square root of 15. Now this one, I will try my calculator with you, clear out whatever I had before. So we're trying to enter in a negative number. This is why I want to do this with you. Not all calculators are the same, so make sure you can identify what your negative symbol is. So I'm trying to type in negative 40 times square root of 15. So my negative right here, it's right here, so that's negative, okay? But it looks like my calculator wants me to enter in 40 first and then a negative. Then multiply square root of 15. Remember, my calculator wants me to enter 15 and then square root, and I do have to hit enter. So, whoa. All right, so the decimal approximation is going to be negative 154.92. My bad, 92. Okay, let's check. Let's move on to multiplication of binomial radical expressions. When we're multiplying, just like any other binomial algebraic expressions, we FOIL. So the first thing we want to do is FOIL. Then we would simplify radicals. Then lastly, combine like terms. So let's FOIL. 3 times radical 10 is 3 radical 10. 3 times radical 5 is going to be 3 rad 5. Rad 2 times rad 10 is going to give us radical 20. Rad 2 times rad 5 will give us square root of 10. Then from here, as you can see, I have 2 of the like radicals. That will give us 4 rad 10, because technically this right here has a coefficient of 1, so we can combine those. Now, I know I'm going to drop 3 rad 5 down because I know rad 20 has a nice square number of 4. That will allow me to simplify a little bit further to, I'm going to write all the steps down, to 2 rad 5. Now that right there are like radicals, so we will combine a little bit further. So that's going to give me 5 rad 5. Okay, this is the simplest we can go in radical form. We also need to punch it in and get a decimal approximation. Remember, I want you to give yourself a try and then come back or hit pause to check your answer. I'm going to give you a couple minutes here. Not a couple minutes, a few seconds. Okay, so now I'm going to turn on my calculator. We want to do 4 times rad 10. My calculator requires me to do all of these steps. 4 times rad 10, so second, oh no, I don't want to do second, I have to punch in 10 and then second radical. So that's the first one. Then plus, I'm going to open a quantity here because 5 rad 5, 5 times rad 5. I'm going to close it up so that my calculator, just to be cautious, so my calculator doesn't think that I'm really combining rad 10 with the 5 there. I'm going to hit enter. So this gives me 23.83. Okay, so hopefully you're able to check that. Let's go back and write that in. Let's move on to example 4. I'm going to change the pen really quickly. There you go. Okay. Let's FOIL this baby out. 2 radical 3 times radical 3, that's going to be 2, and I'm going to multiply this out. As you can see, radical 3 times radical 3. When you have 2 radicals, you can put it under, right? So that means it's really technically it's 2 times 3. When you have 2 identical radicals multiplying each other, you can straight up just write, just simplify it, okay? So this will give us 2 radical 3 times 6 radical 5. I cannot, the radicands are the same, so we cannot just pull out the 3 or the 5. We do have to go multiply this out. So that's going to be 12 radical 15. In the middle, 4 rad 5 times radical 3 is going to be 4 radical 15, and last, that will give us 24. And again, as you can see, this rad 5 and the rad 5, we can just, it's going to be a minus, I lie. So minus 24 times 5. Okay. Then from here, we can go 2 times 3 is 6. These two in the middle, we can combine them. So that's going to give us a negative 8 square root of 15. You want to multiply the 4 times 5. So that's going to give us 120. Then from here, we're going to simplify the 6 and a negative 120. That's going to give us a negative 114. Take away 8 rad 15. Box that up. Now go ahead and use your calculator to punch in your decimal approximation. So you can box up your answer that way. And you're going to do that on your own, okay? Any of the answers or any of the approximations that I'm not giving you, that's your job to do on your own. Number 9, 5 times 5, that's going to give us 25. 5 times square root of 7, that's going to give us 5 square root of 7. In the middle, negative 7 times 5 is negative 5 square root of 7. Negative 7 times positive 7, you can write square root of 49, or you can go and write negative 7 straight up. Now in the middle, as you can see, you can cancel these two guys out right away. So those are gone because those are exactly the same. So 25, take away 7, it's going to give us 18. 18 is not an irrational number, so we do not need the decimal approximation. Now, notice how all of these answers right here have some sort of radical in them, right? Well, this right here, we came up with an answer of a whole number. Now look at those two binomials. Everything is exactly the same except the sign in the middle. So I'm introducing you the word conjugate. A conjugate is formed by changing the sign between the two terms in a binomial expression. So a couple of things right here. Only the sign between, which is the sign in the middle, not in the front, and only in a binomial expression. So anytime you have two identical pairs, right, to accept the sign in the middle, they are opposite of each other, then that means those are conjugate. So in a conjugate, the middle, let me get a different color pen, the middle right here will always disappear. So guess what? You don't have to multiply the middle. You just need to multiply the first two and the last two. Yep. And then combine like term and you should have your answer. Now, if you don't remember that, don't worry, just FOIL that out and you should get your answer. Simple division. Divide the coefficient, divide the radicand, and of course in mathematics you have to simplify. Instructions the same, give me the exact simplest radical form and then decimal approximation. So in this one, since our coefficients are both 1s, I only need to worry about the radicands. So 40, I'm going to make this radical bigger. Again, just like multiplication, when you have two different numbers under two different radicals, you can put them under one big ginormous radical. So 80 divided by 5 is going to give us square root of 8. Simplify square root of 8 because 8 is really 4 times 2. Square root of 4 is really 2. So that's going to give me 2 rad 2. Go ahead and enter that in and give me a decimal approximation. Now number 11, 12 divided by 4, those are your coefficients. Make a big radical. Do 18 divided by 6. 12 divided by 4 is going to be 3. 18 divided by 6 is also 3, but it's under a radical, so big difference there. Use your calculator and find your decimal approximation. And if you need to, hit pause. Number 12, their coefficients and 5 and 10. Multiply those out, make a big radical. 27 divided by 9. So 5 divided by 10 is really 1/2. 27 divided by 9 is really a big radical of 3. Well, look at that. It's kind of a funky way of writing it, right? Well, this is really radical 3 over 1. So a preferred answer would be radical 3 over 2. That's okay to write, or do 1/2 times radical 3, just like what we had earlier, but make sure you write it in the way that you like, okay? Now use your decimal, write your decimal approximation in there. Square roots are irrational numbers. Sometimes it is easier to deal with fractions with a rational number in the denominator. Therefore, we practice rationalizing the denominator. So in this box, it says monomial radical in the denominator. You want to multiply the numerator and the denominator by the radical expression that will make the radical in the denominator a perfect square, because we can always take the square root of a perfect square. And then lastly, always simplify. Examples 13 to 15. Rationalize the denominator and then give me the answer in the simplest radical form and round it again to the same directions as earlier, to the 100th place. So we have 5 divided by 2 square root of 3. Well, because this is a square root, to rationalize it, we need 2 identical numbers. So that's why we're multiplying the numerator and denominator by the same exact radical. So this is really now 5 times radical 3 on the top, 2 on the bottom. Technically, I have 2 square roots of 3. Well, 2 square roots, that's really a pair. So that's why it allows us to clear the radical in the denominator to give us an answer of 5 times square root of 3 all over 6. Okay. Now, if you don't believe me, go ahead and use your calculator to give me the decimal approximation. Now, you can punch this in your calculator, but make sure you're cautious. Okay, so let me pull that up, because you want to tell your calculator to enter the numerator, especially when you have a calculator like mine where it's not as easy to see. So I'm going to clear out my old stuff. You want to do quantity 5 times radical 3. Okay, and we'll close that up. Then I want to divide it by 6 and hit enter. I have 1.44. So make sure you're very careful of how you entering this in. Now, if you're not sure when or where to put your parentheses, then just do it one at a time, okay? Do 5 times radical 3. Hit enter. Oops, I forgot the radical sign. Don't. 5 times. And then second, there you go. Radical 3, hit enter. Then now take it and divide it by 6 and then hit enter. So you still have the same answer. So if you need to, do multiple steps. Now, in addition, I want you to punch in the original fraction, which is 5, this one right here, which is 5 divided by 2 radical 3. And then see if it's the same exact decimal. Okay, so 5 divided by, open parentheses, 2 times 3, and then I make sure I put radical in there, and I'm going to close that up. Look at that. The decimal approximation is identical, so you know you were doing the question correctly. All right, let's move on. Now, as you can see, this is one big ginormous radical. That's okay. If you can put 2 radicals under one big radical, then you can go backwards. Now, I'm going to multiply the denominator by rad 5. What you multiply to the denominator, you will multiply to the numerator. On the numerator, you now have square root of 10. On the bottom, you have 2 radicals of exactly the same radicand. Therefore, you can simplify. Box that up. I do need you to find your calculator and give me the decimal approximation. On this one, before we go and multiply the denominator by a particular radical, I want to simplify because I know 4 have a nice number of 4 in there. I'm sorry, 8 is what I'm looking at. So 8 is 4 times 2, so square root of 4 is really 2. This is now really 2 rad 2. Technically, you can simplify this a little bit by dividing top and bottom by 2. So that will give me 2 on the top and just square root of 2 on the bottom. Now we will go in and multiply top and bottom by square root of 2. That will give us 2 rat 2 on the top and just 2 on the bottom. Whoa, you can simplify a little bit more. I'm going to make my pen a little bit smaller. There you go. So you can simplify those out, divide both top and bottom by 2. Final answer is just going to be a square root of 2. So go ahead and use your calculator, punch in square root of 2, give me your decimal approximations there. One last set. Here we go. Binomial radical in the denominator. What do you do when you have 2 terms in the denominator? This is where the conjugate will need to be used. Multiply the numerator and denominator by the conjugate of the denominator, and of course we simplify. Same instruction, give me radical answer and roundabout. Okay, so the conjugate of the denominator, only the denominator, the conjugate, the only thing that we're going to change would be the sign in the middle. The denominator has 5 minus 2 rad 5. So I'm going to change that sign immediately to plus. So it's now really 5 plus 2 rad 5. What you multiply to the denominator, you have to multiply to the numerator. And then FOIL. Ready? On the top, 2 times 5, that's 10. 2 times 2 rad 5, that's going to be 4 rad 5. Now, in the middle, rad 5 times 5, that's 5 rad 5. Rad 5 times 2 rad 5, I'm going straight to 2 times 5 right away, because rad 5 times rad 5 is rad 25, which is really just 5 all over in the denominator, because those are conjugate. So all I have to do is multiply the first 2, which is 5 times 5, which is 25, and multiply the last 2, because we knew earlier that the middle 2 terms will cancel each other out. So 2 times negative 2 is going to be negative 4. Rad 5 times rad 5 is just simply 5. And we're going to simplify some more. 10. This 4 rad 5 plus 5 rad 5, that would give us 9 rad 5. And in the back is another 10 all over 25 minus 20. This is now 20 plus 9 rad 5 all over 5. Box that up. Now I'm going to teach you how to use your calculator to give me the decimal approximation. And mind you, if you don't know how to enter it all in at once, make sure we just take it one step at a time. Clear out my old stuff. Here we go. I'm going to just do the numerator. Are you ready? So the numerator set is 20 plus 9 times square root of 5. Enter. So that's just the numerator. So you notice how I hit enter for just the numerator? Now I'm going to take that answer and we go divided by 5. Hit enter. So I took it 2 different steps and I got 8.02. Now, if you are more advanced or your calculator allows you to do all in one set, totally fine. I normally want to put a set of quantity on the numerator or the denominator anytime you have multiple terms. So I'm going to go, okay, 20, this is me doing it again in one step, plus 9 times square root of 5. I'm going to close that up with a parentheses. Then I'm going to divide the whole thing by 5. Hit enter. I should have the same exact decimal as 8.02. Go back to your notes and write that in as our decimal approximation, because the next couple of questions you're going to have to do that on your own. Okay, so example 17, 2 plus radical 6 divided by 2 minus radical 6. Remember, we're looking to multiply the conjugate of the denominator only. The denominator has a 2 minus radical 6. So the conjugate of that will be immediately plus. So it's going to be 2 plus radical 6. Okay? You don't need to look at the numerator at all when you're looking for the conjugate. We're looking at the denominator only. So we're going to distribute. 2 times 2, that's going to give us 4. 2 times rad 6, that's going to be 2 rad 6. And then in the middle, rad 6 times 2 is going to be 2 rad 6. rad 6 times rad 6, it's just going to be 6. Notice on the numerator, these two are not conjugates of each other because the signs are not opposite. Okay, conjugate means the signs must be opposite of each other. Now in the denominator, those are conjugate of each other, so I would only need to multiply the first two and the last two. So that's the beautiful part of that. Radical 6 times radical 6 is just 6. Combine the like terms. 4 plus 6, that's going to give us 10. Then we have 2 rad 6 plus 2 rad 6, that's 4 rad 6. On the denominator, 4 take away 6 is a negative 2. No, we are not done. On the numerator, we are going to factor out a 2. So, take out 2 from a 10, that will give us a 5. Take out a 2 from a 4 in the front, right here, that's going to give us 2 radical 6. And then over negative 2. Now we can simplify, divide both top and bottom by a 2. Well, then I'm going to end up with a 5 plus 2 radical 6 divided by negative 1. Well, that's really not pretty, so what you want to do is divide negative 1 to both terms on the numerator to get negative 5 minus 2 radical 6. This is the final answer. I do need you to go and punch in your calculator to give me your decimal approximation. One last one. Okay, look at the denominator and make sure you can identify what the conjugate is. The denominator has 4 minus radical 3. So immediately the conjugate is the same except that we're going to change it to 4 plus radical 3. Okay, so 7 times 4 and 7 times radical 3, that's going to give us 28 plus 7 rad 3. In the denominator, 4 times 4 is 16 minus radical 3 times radical 3 is going to be 3. Notice how I do not need to worry about the two middle terms in the bottom because as we know, those are conjugates. They will cancel out the middle terms, that is. All right, so this is 28 plus 7 radical 3 on the top divided by 16 minus 3. That's going to give us 13. Now, most likely, I want to say, okay, well, can I simplify? On the numerator, you can technically take out a 7, right? But the 13, it's already a prime number. So even if you're able to take out a 7, you can't really cancel. But it's not wrong to take out a 7 because 7 times 4 is 28. So you're going to go right 4 plus rad 3 all over 13. That's also okay. All right, one last thing you must do for yourself here is give me the decimal approximation on that one. Now, what I want you to do is write yourself a note. When multiplying conjugate pairs, what happens to the two terms in the middle? I want you to finish that thought. When multiplying conjugate pairs, the two terms in the middle and then blank, blank, blank. Okay? All right, this is it. Enjoy your day.